Hey guys, Mr. Lloyd here. I'm going to work with you on part 2 of the homework for Thursday, April 16th. Still getting the dates, still having trouble with the dates. It says on the top of the page 6-5 homework, and let's get right into it. Problems 1 through 3, you don't have to do any computation. We're just taking a second to think about all the parts of volume, thinking about length, width, and height, and multiplying them together. And so we're just going to do a couple quick equations here. So let's look at problem 1. Each edge of a cube is f feet long. If v is the volume of the cube, write an equation relating f and v. So this one's pretty straightforward. Each edge is f feet long. F is, of course, an unknown value. So we just write it. It's a cube, so each one of these is the same measurement, of course. Volume equals f times f times f. Each f stands for length, width, and height. Or, if we actually multiply them together, you could have written the equation as f cubed, f to the third power. Number 2, similarly here, a rectangular prism has a square base. Square base should tell us that the edge length of each, the length and the width are the same, equal, square. And the edge lengths are e and height is r. Write an equation relating these. So again, we could write v equals e times r. That would, of course, be length times width times height. Or I can multiply length times width together. E times e is e to the second power, or e squared. Whoops. Number 3 is pretty similar as well. A rectangular prism is 6 centimeters tall and has a base of area c centimeters squared. So c here, don't get confused. This should just be, understand this is a variable that stands in for a value. So that value could be whatever. We don't know what it is. And we're just going to write an equation relating c and v. So volume would equal area, c, times height. Okay? That's all we do there. C times 6 or 6 times c. Numbers 4 through 5, I'm just going to tell you guys, these were complicated problems, so I'm not going to be grading you on accuracy here. I'm just looking for an effort on the rest of the page because these were tricky problems. I'm going to show you on my notebook paper here how I solved. First, we'll start with number 4, and I'm just going to tell you number 4 took me the whole page here. I did write a lot of explanation and kind of took my time, but it does take a lot of work to solve number 4. So the first thing we're going to do is we're going to write down the length, width, and height that we were given. And these are just taken straight from the problem here. And then I remember my equation for volume is length times width times height. I have to find the volume of the box first, and then I'm going to find the volume of the peanuts, and we'll get down to that in just a second. But first thing I do, I write out my equation with my values in there, and I convert each of my mixed numbers into improper fractions, as you see here. I first multiply 21 halves by 17 halves to get 357 over 4. Then I multiply that by 12, and I get a final value of 1,071. And I circled it. That's the volume of the box. I circled it, but I did it in dotted lines to kind of indicate to my brain it's sort of a step toward the answer, but it's not really the answer yet. And that's oftentimes, this is a kind of a mistake we can make, because the problem said the box is only 2/3 full of peanuts, and it's asking us not to find the volume of the box, which we found right here, but to find the volume of the peanut. So here I sketched the box, and I drew a line that says 2/3 full of peanuts, so you can think of everything underneath the line as full of peanuts, and everything above the line is empty space. And so V, the volume equals 1,071 inches cubed for the whole box. To find the volume of the peanuts, if it's only 2/3 full, then I'm going to multiply by 2/3. And I go ahead and do that, and my final value for the peanuts is 714 inches cubed. So again, if you didn't quite get this answer, don't get too worked up about it, because these are very kind of tricky problems, and these are problems that, to be honest, if we were in a regular classroom setting, these would be problems we would do as a whole group. I wouldn't ask you to do these independently, because these are pretty tricky. Let's move on to number 5. Number 5, we're given actually, I'm going to pause the video and I'll do the rest of the problems on the next video. See you then.